All right, welcome to my presentation. So this here is a lot to take in, so I'll give you the basics. My name is Jaron Beluyet, and today I'm going to be talking to you about how prey may be used in buildings to protect themselves from predators. Interesting. Before we go into that, I'm going to give you a little scenario. So imagine this. It's late at night, and you're on the road driving home. It's a road you've been on countless times before. The radio is playing in the background, and you're just thinking about what you're going to do once you're home. Then, in the flicker of your headlights, a deer's eyes gleam on the side of the road. As you slow down, it's not one, but 3 deer on the side of the road. Has this happened to you? If so, have you ever thought to wonder why they were near the road? Or even further, why does this only happen at night and not the day? Well, this brings us to my topic of study, the human shield hypothesis. The human shield hypothesis suggests that prey reside near human infrastructure as protection from predators that are likely to avoid humans. According to this hypothesis, those deer you saw on the side of the road may have been avoiding nocturnal predators. Here's another example. A past study in the greater Yellowstone area found that pregnant elk gave birth closer to roads in order to avoid the predation of bears. The human shield hypothesis has been assessed with radio telemetry, but few studies have utilized camera trap data. With the assistance from Roland Kays and Daniel Choi from North Carolina State University, my team and I wanted to know whether prey species were residing closer or farther from buildings in order to avoid predators. We created the following objectives for our analysis. First, analyze a snapshot USA subproject location. Second, determine if there is a statistically significant relationship between species detection rate and distance to buildings. Third, compare species detection rate to predator-prey relationships. Now here's how we met those objectives. We chose Snapshot USA data from the U.S. Air Force Academy in Colorado. This location had 27 cameras, over 27 sites, both near and far from buildings, and it had numerous species. The prey species we observed were cervids and various squirrels. The predator species we observed were mountain lions, bobcats, and coyotes. Scary bunch. We chose these species because of their unique predator-prey relationships. Mountain lions, the apex predator, eat cervids, coyotes, and bobcats. Coyotes and bobcats, the mesopredators, eat squirrels. Using a GIS file of every building in America, we were able to calculate how far the nearest building was in meters from each camera. We also calculated species detection rate for each camera, so we could know whether a species was being detected more or less often at a specific site. After graphing these two variables together, these were our results. These were not our results. These were our results. We found that cervids had a higher detection rate near buildings. Squirrels had a higher detection rate farther from buildings. And for predators, coyotes and bobcats had a higher detection rate near buildings, whereas mountain lions had a higher detection rate farther from buildings. So what does this all mean? This is a bunch of mumbo jumbo, Jaron. I'm not making the connection. Well, I'll tell you. Our data fully supports the human shield hypothesis when considering the predator-prey relationships between these animals. Mountain lions predate on cervids, coyotes, and bobcats. To avoid the mountain lions, these species resided closer to buildings. Coyotes and bobcats predate on squirrels. To avoid the coyotes and bobcats, squirrels resided farther from buildings. Although there was practical significance in this analysis, there was not enough data to build statistical significance between the detection rate of individual species and proximity to buildings. Further research can obtain better data by using more camera traps and keeping them out for longer periods of time. In the future, humans will only expand further onto natural lands. Will predator-prey relationships continue to be affected by human development? And how is that affecting ecosystems as a whole? This is something for future research to address. That's the end of my presentation. Once again, my name is Jaron Baluyat. If you have any questions, you can connect with me on LinkedIn. This is my page right here. Or you can email me at jjbaluyo@ncsu.edu. Thank you for bearing with me and my stutters. I appreciate you watching my talk, and I hope that you have a fantastic day.